Hello all, hello and welcome this side Teja. I'm Teja. Welcome to Curious Farmer YouTube channel. In this lecture, we will be discussing about lactose, um, a commonly used ingredient in pharmaceutical industry. Lactose is a sugar found in milk and dairy products. Before going to talk about lactose, previously part one we have discussed about what are pre-formulation studies and what is diluent, and examples of diluent is lactose. In this lecture, we will only focus on lactose. And part three lecture, I will be focusing on starch. It is also diluent, and part four mannitol, part five sorbitol, and part 6 microcrystalline cellulose MCC. It is also diluents. These are the examples of diluents. In this lecture, we will discuss about lactose. Okay. See, lactose is a, as I said earlier, sugar found in milk and dairy products. It consists of two sugars. What are the two sugars? Glucose and galactose. Right? Linked together. Okay. Lactose is widely used in pharmaceutical as what I said inactive ingredient. Inactive ingredient like a excipient, it can be used. It serves as a it serves several purposes, including, as I said, diluent, fillers, and like now let's discuss about. Previously, we have discussed about lactose is a like in the diluent concept. It is used in tablet manufacturing, as we discussed previously, because of its physical and chemical properties. And what is the key advantage of lactose as an excipient? Where previously in part one we have discussed what are the what can we call key advantage of the lactose as an excipient. Come on, one is compressibility, and another one is good flowability, and another one is allowing good allowing for efficient tablet production. These are the key advantages of the lactose. See, this is the most widely used as a dilute. This is we know. This is water solubility. This is you know. Today we'll discuss about why, what is lactose, how, where it will be used. See, lactose, it will be it has two forms, anhydrous and hydrous, as well as anhydrous. Hydrous lactose is used in wet granulation. Why it is used in wet granulation? Why not in dry granulations? So, see, hydrous lactose. What does it mean by hydrous lactose? Anyone, do you know about what is exactly hydrous lactose? Hydrous means water. For example, consider this is the lactose. Hydrous means water molecules around it. This is what we call hydrous. Hydrous means nothing but water, and anhydrous means without water. See, anhydrous means the name itself suggests that refers to lactose that doesn't contain any water molecule. That is what we call anhydrous. See, hydrous lactose is preferred in wet granulation. Why? Before reading anything, we should question ourselves why not in wet granulation? Because um, hydrous lactose used in as a diluent because in wet granulation, because hydrous lactose has good what it has in good binding properties, meaning that it can effectively bind and agglomerate the powder particles together when mixed with liquid, liquid binder. It is having good binding properties. That's why the presence of moisture, the presence of moisture in what we call the presence of moisture in hydrous lactose. For example, this is the hydrous lactose. The presence of um, moisture in hydrous lactose aids the cohesive, granules. So this is the first advantage. And while talking to second advantage, it has good flowability as well as good compressibility. What does it mean? Hydrous lactose exhibit desired flow and compressibility characteristics, making it suitable for tablet manufacture. This is the thing. So now let's talk about anhydrous lactose. As I said, anhydrous, the name suggested, lactose doesn't contain any water molecule. Anhydrous lactose is known for its what we call fast. It is not changing. Okay, fast disintegration. See why? Why anhydrous lactose is known for its fast disintegration properties? Because of low moisture content. Anhydrous lactose having low moisture content when compared with hydrous lactose. So what happened? Absence of water molecule in anhydrous lactose in a dry and a less cohesive powder. So this low moisture content, what it does, low moisture content provides rapid disintegration. See, for example, when a tablet comes contact with the moisture, such as consider this is a saliva. What happens when a tablet comes to contact with moisture such as saliva? The absence of water prevents the formation of viscous viscous gel-like structure that can impede disintegration. So that's why it has fast disintegration. See, simple thing is anhydrous, it doesn't contain any water molecule. This is dry state. When saliva comes in a contact, any liquid content, it dissolves very fast because it is anhydrous. The second thing is that because of anhydrous lactose exhibit excellent. I will rub this. Wait a minute. It is eraser. Okay, I will rub. Now I'm getting space so that I can explain in better way. Okay, okay. Where I am now, what I'm telling, anhydrous lactose exhibits excellent ability, right? Which refers to ability to absorb what? Anhydrous absorb moisture. It readily absorbs moisture or the liquid. When anhydrous lactose tablet comes in a contact with what we call saliva, it quickly absorbs moisture, causing rapid disintegrate quickly. That's why and that's why the enhanced wettability ensures effective effective uptake of moisture. So facilitating what it facilitates, breakdown of tablet into, for consider this is a tablet, break down the tablet into smaller particle, right? It break down the tablet into smaller particle. That is why enhanced wettability and low moisture content of the anhydrous lactose uh, leads to fast disintegration property, and it having good friability and no sticking, no capping. And wait, give me a second to rub this so that we'll discuss. Mm, yeah. Now let's talk about the important property, like what can I say, Maillard reaction. What exactly it is? This is important because uh, the, I think you will get questions from this. What is happening to my laptop? Okay, you can get questions from this Maillard reaction. What exactly Maillard reaction is? See, why should we study Maillard reaction? See, what exactly Maillard reaction is. Um, I need space. Okay, we'll discuss here. Okay, see what exactly Maillard reaction is. Maillard reaction is a chemical reaction that occurs between what reducing sugars and amino acids, right? Amino acids or proteins. Proteins are the units of amino acids. Okay. Uh, See, Maillard reaction, it occurs between reducing sugars, this is called reducing sugars, and protein or amino acids. When exposed to heat, it is responsible for what we call browning or flavor development in various cooked food, such as here I mentioned what bread crust or roasted coffee beans or grilled meat. See, for us, food is doesn't matter. We are talking about sutics, pharmaceutics. It all relates to tablets. So now, when it comes to tablets, specifically those contain lactose. Lactose is a sugar, right? The Miller reaction can potentially occur in certain conditions. What are the certain conditions? See, first you have to understand what is lactose. Lactose, as I said previously, lactose is a disaccharide sugar found in milk. It's a reducing sugar, like it is having what we call free carbonyl group, a reducing end. For example, a lactose having free reducing sugar, right? Free reducing sugar, how it is having free reducing sugar, that I already explained. See, for example, how can I say that a disaccharide is composed of glucose and galactose. That you know now, it is considered as a reducing sugar because it has a free carbonate. That's why it is considered as a reducing sugar that undergoes chemical. See what happens during Maillard reaction. That reducing sugar reacts with amino acid or proteins through the complex chemical reaction when exposed to heat, and it forms like brown in color. See, let's in detail discuss about this Maillard reaction. This is what actually happened with lactose. Lactose undergoes when sugar is nothing but lactose protein when exposed to heat, it forms brown. Yeah, that is what about lactose.